Hey, Cyber Tutor here. In the world of networking, knowing exactly where data is coming from and where it's going is crucial for keeping networks secure. That's where MAC addresses come in. A MAC address, or Media Access Control Address, is like a unique fingerprint for each device on a network. Let's break it down and look at how it connects to MAC filtering and network segmentation. A MAC address is a unique identifier given to each device's network interface card, NIC. It's a 12-digit hexadecimal code and it's assigned at the factory, meaning it's specific to that device and can't be changed. Think of it like a serial number for your device on the network. Every time your device connects to a network, it announces itself using this unique MAC address, which helps routers and switches identify it. In cybersecurity, knowing the MAC address of each device is useful for monitoring traffic, controlling access, and even tracking down devices if something suspicious happens. Since MAC addresses are unique to each device, they help network admins see exactly who's connected to the network and trace back any unusual behavior to its source. Now let's talk about MAC address filtering. Think of it as a gatekeeper that controls who can join a network. With MAC filtering, network admins create a list of allowed MAC addresses. Only devices with those approved addresses can connect, and all others are blocked. This is especially useful for securing smaller networks, like in offices or schools, where you want to limit access to trusted devices. Here's how it works. On your network router, you set up a whitelist of allowed MAC addresses. When a device tries to connect, the router checks its MAC address against this list. If it matches, access is granted. If not, it's blocked. This way, only approved devices, like company laptops or employee phones, can access the network. It's a simple but effective way to keep unwanted devices out. While MAC filtering adds a layer of security, it isn't foolproof. MAC addresses can be spoofed, meaning an attacker could disguise their device's MAC address to look like an approved device. So while MAC filtering is helpful, it's best used alongside other security measures like password protection and network encryption. Now let's talk about network segmentation. Segmentation divides a larger network into smaller sections, or subnets, each with its own set of rules. For example, you might create separate segments for the HR, IT, and sales departments. By using MAC address filtering within each segment, you can control exactly which devices can access each area, adding more control and security. In cybersecurity, segmentation is crucial for containing threats. If an attacker gains access to one segment, they can't easily jump to others without passing additional security checks. Imagine a company's office network where HR, IT, and sales each have separate access needs. With network segmentation, each department has its own subnet. Then using MAC filtering, only devices assigned to each department can access their specific subnet. For example, HR laptops can access the HR segment but are blocked from sales or IT. This reduces the risk of data leaks and limits potential damage if an attack occurs in one area. So to recap, MAC addresses identify devices uniquely on a network, like a fingerprint. MAC filtering helps control who can access the network by creating a list of approved devices, while network segmentation divides a network into smaller, more secure parts. Together, these tools give you more control over who accesses each part of your network, which is a critical layer of defense in cybersecurity. Thanks for joining today. If you're finding our Network Fundamentals series helpful, be sure to check out our previous videos, like the one on IPv4 versus IPv6. And don't forget to like, subscribe, and hit that notification bell for more updates on cybersecurity fundamentals. Stay informed, stay secure, and see you next time.